everyone. In this project we want to see how we could control a continuous servo motor with the variable resistor. So let's see which component do we need. We have Tiva C series Launchpad, we have our variable resistor, and also the continuous servo motor. So let's see how it should be work. I'm turning this actually to this side. So as you could see, whenever I actually turn that slowly, I could be able to control the speed is turning to the clockwise, and also I could control its speed with turning these potentiometers. So I'm actually turning more, it's actually turn faster. So whenever I turn the potentiometer to the opposite direction, I'm able to control the speed. Okay. So now, if I actually turn that more, I could somehow turn that to the counterclockwise to do that. So see right now counterclockwise. So now is clockwise. So I'm able to control the direction. So whenever I'm turning that counterclockwise, still I'm able to control the speed. So if I want to actually turn that faster, so see I turn the potentiometer more and able to actually even control the speed whenever I'm actually turning the counterclockwise. But to do that again, so go to the clockwise, slow, then actually go faster. Again back to here and make that slow, then actually change the direction. So now counterclockwise is slow, so now I'm actually able to turn that faster. So let's take a look to the circuit diagram and the code and see how we could do that. So let's take a look to the circuit diagram. So as you could see here, we have, this is our servo, this is our external power supply, this is actually the continuous servo motor that we have, and this is our variable resistor, and this is Tiva C series Launchpad. So the ground of continuous servo motor connect, which is the black wire, connect to the negative of the external power supply, and both connected to the ground of the launchpad. So the red wire in your continuous servo connected to the positive of the external DC power supply, and the white, which is the signal of your continuous servo motor, connected to the port PF1. So the variable resistor, one side goes to the ground, the other side goes 3.3 volt, which you have in your launchpad, and the middle pins goes to the PD0, which is somehow, this is our analog to digital converter pins. So just make sure the old ground, the power supply, external power supply ground, and also the launchpad ground connected together. So let's take a look to the codes and see how it works. The code is very simple. So we use the Servo library. So we declare two variables, which first one is the integer var, and the next one we declare the PD0, which is whatever we got, we actually put and label that potentiometer. So in the setup, so you just say use the attach function PF1, which is the white wire in your servo. This is pulse width modulation signals, and in the loop you read whatever you have in from PD0, keep that inside the variable. And if you remember, in previous video I explained whenever you use the write function with continuous servo motor, here you could have the number, the value between 0 to 180. So 0 means counterclockwise, so 180 clockwise, and in the middle, which is the 90, you could stop your servo. So if you move from 90 to 180, you could actually control the speed. If you move from 90 to 0, again you are able to control the speed, but this time you are actually turning in the opposite direction. So we are doing exactly the same thing, but this time we actually get these value from potentiometer, from our analog to digital converter. So that's the reason you read whatever you have, any value that you got from potentiometer. So then that's value, because your analog digital converter in Tiva C series launchpad is 12 bit. So that number will be between 0 and 4096. But whatever you use here in the right function, it should be between 0 and 180. That's the reason you use the map function. It is somehow map these range to the 0 to 180. So then depend on that value, it's actually you write that inside the right function, and definitely you are able to turn the continuous servo motor to clockwise, counterclockwise, and also you are able to control its speed, because when changing the variable resistor, you are able to get these number of the range 0 to 180. So that means whenever here you could put 0 to 180, definitely you are able to turn that counterclockwise, clockwise, and also stop it, and also control the speed whenever you are turning in any direction that you have. So let you load the codes and see if it works or not. So we upload the code. Let us see is it works or not. So I'm actually turn the variable resistor. It's actually turn clockwise, and it's very fast. I actually able to control its speed whenever it's turning the clockwise. I could actually turn that counterclockwise, and also I am able to control the speed whenever I'm actually turning that counterclockwise. Again, clockwise, faster or slower based on what you do need. And also the counterclockwise, I could actually turn that faster or slow. Thank you so much for watching this video, and I hope you like this project.